Okay, so that was the first example. Let's have a go at another example. Okay, here we go. Let's read this question. From the top of a cliff, Andrea spots a boat out at sea. If the top of the cliff is 42 meters above sea level and the boat is 90 meters away from the base of the cliff, find the angle of depression from Andrea to the boat to the nearest degree. Okay, cool. Let's underline the keywords. Now that we've read the question, let's underline the keywords. Okay, so if you have a look at that first sentence, from the top of a cliff, Andrea spots a boat out at sea. This part doesn't really need anything underlined. We don't really need any of that information. It could be, Andrea could be on the top of a tower. Andrea could be in a spaceship. It doesn't really, and she could be looking down at something, but it doesn't really matter. So let's not underline any of this. Okay, the next part is important. The top of the cliff is 42 meters above sea level. So we're going to have 42 meters above sea level. And the boat is 90 meters away from the base of the cliff. Okay, so there we go. So we can use this information to draw a diagram. So let's have a go at doing that. So we've got a cliff over here. And Andrea's at the top of the cliff. Let's give her a nice haircut there. And we've got a boat which is 90 meters away. And so here this is 1, 2, 3, 4, 5. Let me just make it a little bit kind of close to scale. And okay, so here the boat is 90 meters away and the cliff is 42 meters high. And there's a boat out here. We're also on the sea, so let's draw some waves for the sake of it. Ooh, got some waves. And there's a boat out here. It's got a red little flag. Oh, that's not red. Got a red little flag out on this boat out here. Okay, cool. We've got a boat. We've got our sea. We've got Andrea at the top of the cliff. Okay. Now Andrea's looking down at this boat. I'm going to draw it more accurately so we form a right angle triangle there. Okay, so we've done step one. We've read the question, we've highlighted the keywords, and then we've also drawn a diagram to represent. Okay, next part. We want to figure out what is the question asking us to do. Okay, let's have a read. Find the angle of depression. Find the angle of depression from Andrea to the boat to the nearest degree. Okay. So if you remember angle of depression, we go from the horizontal from the top. And then we go down, and this is the angle that we're looking for. Now if you have a look at my diagram here, this angle isn't actually in the triangle down at the bottom here. We want to actually use this triangle here because if we have a right angle triangle, we can use trigonometry. And I hope you can start to see that this thing here is in fact a right angle triangle. So let me just put a right angle at the bottom here so we can see that this is a right angle triangle. So that angle theta, this angle of depression actually isn't in my diagram. However, when I was talking about angles of elevation and depression, the one key trick that we need to note is that for angles of depression and elevation, if they're in the same diagram, they're the same. So here, this angle of depression is actually the same as this angle at the bottom here. Because what did we say? They were alternate angles. Alternate angles have the same size. So this angle at the top over here, so if I can, let me just undo this highlighting. Oop, that was a little bit off. That's okay. This angle at the top here is going to have the same value as this angle at the bottom here because they are alternate angles. Okay. Now that we've got that, let's try to figure out what this angle is. Now, what we want to do is we want to still do our regular steps that we've been doing when we're solving for right angle triangles. So let's label the sides. I go across from my right angle. So this side over here is my hypotenuse. I don't have a value for my hypotenuse for this question, so I'm not going to need to deal with it. Then I go to my angle. Now in my diagram, my angle is this theta here. I don't know what this angle is. It's an unknown angle. So I'm going to go across from theta. And so that side is my O side. So my 42 meters is my O side or my opposite side. What I'm left with is my 90 meters, which is at the bottom here, which is my adjacent side. O and A, which is similar to the previous question, I'm going to use tan. Now here, let's stop to think. What's the question asking us to find? Are we finding a side or are we finding an angle? Well, if you have a look, the question is asking us to find an angle of depression. I hope that's a hint, because we're going to be finding an angle. If you remember, what type of trigonometry do we need to use if we're trying to find an angle? We're going to use inverse trigonometry. So here, for this question, we're not going to use inverse tan. We're not going to use regular tan, I mean. We're going to be using inverse tan to help us solve this problem. Okay, so in terms of operations, we need to use inverse tan, so we're going to need to use inverse trig into our calculator. Now, regardless, we still need to use the same steps to do our equation. So let's still write the equation here. So just remember, we want to write the equation. So here, this question involves tan, so we still want to write tan, and inside my tan, I'm going to put in my angle, so angle theta. So angle theta is my unknown angle. I don't know what theta is. And that's going to be equal to opposite over adjacent. So here it's going to be 42 over 90. Okay, great. Now I want to be solving for theta. So I want to rearrange this to solve for theta. What do? Well, I need to use inverse tan. So I'm going to use tan inverse of my ratio. Just remember, inverse trig, we put in a ratio into inverse trig and we get out the angle. So for inverse trig, we put in a ratio and we get out the angle. Okay, so we're going to use theta is equal to inverse tan of 42 over 90. Let's put that in a calculator. So here we're going to I'm going to put inverse tan, so shift tan 42 over 90. And I need to close the bracket. And that gives me 25 degrees and 0.0618. So if you have a look at the question, it will ask us to find it to the nearest degree. So here we're going to just have 25 degrees. So theta is equal to 25 degrees. So this question, we needed to find an angle. So when we're dealing with angles, we need to use inverse trig when we're rearranging. The same steps still apply. We're still going to label and identify. We're still going to write a trig equation. So when we're writing the trig equation, just be careful. We're not writing inverse trig at that point. I'm sorry if I've confused you. When we're writing the equation, we're not writing inverse trig at that point. When we rearrange and solve, however, if we're finding an angle, we need to put in inverse trig. So that's how we apply Newman's analysis and also the steps that we've been doing so far with finding missing angles and sides with trigonometry together to help us solve trig problems. So to sum up, hopefully by the end of this lesson, you've been able to see how we can visualize a problem by identifying, labeling, by reading the question and underlining keywords and then drawing a diagram. That's a really important step, particularly when we're dealing with these right angle triangle problems with trigonometry. Then we were able to apply Newman's analysis and our regular solving for missing sides and angle steps to help us find whether it is a missing angle or missing side. Have a go at the questions in the chapter, and if you have any questions, feel free to email me or send me a message, Unites.